Hello there, I just left 2 strombolis in the oven. Yay, negligence. Okay, so where we left off, we just solved for, I think, DE, and we figured out AD. Both of those were pretty quick. And we got these two sides as well, the AC and the CD parts. So what's left? We got, well, all these left. Okay, what should we solve next? Well, how about we look at it this way? Actually, what way should we look at it? Just trying to figure out the best way. Oh, okay. This is a good one. This is actually going to be a bit of a pain, but it actually won't be that bad, but basically we're going to have A being pulled on by C, A being pulled on by D, so E has to be pushing it back up, and this is all in the vertical direction, right? Because if you just figure if C is pulling it at some diagonal direction, that means that A is being pulled down somewhat by C, and it's being pulled down by D. So that means that E has to be keeping it up. So, how much force is E going to be exerting? Well, it's just going to be, it has to be equal to what these two add up to, right? Except the vertical part here. So, how can we kind of express this? Because right now it sounds like I'm rambling. It sounds kind of stupid, I'm sure. So basically, this AE in the vertical direction, at least, AE in the x direction is gonna just be the sum of AD, and right, that's all. Y direction. AD, that's gonna be all in the y direction, plus AC in the y direction. So it's just the vertical part of this plus the vertical part of that equals the vertical part of this, which that should kind of make sense to you, I hope. Basically, however hard A is being pulled down, E has to push back up. So what do we get? We get well, what's AD? AD is 7. Whoops, 7 plus. Oh, sorry. Let me put this in. AE in the y direction equals what's AD? AD is 7 plus what's AC in the y direction? Well, actually, we already know that, right? That's kind of what we started out with here. That's 5. Remember, if you want to go back to the second video, and I show you why it's 5, but that's 5. So actually, quite easily, that equals 12. But what does this mean? That AE in the y direction equals 12. That means that, remember, if this is the angle, what's the opposite, right? What's the height of this triangle of forces here? Well, it's just going to be, actually, now that I think about it, I'm kind of wondering if I could use Pythagorean theorem here. I'm going to test it, but I'm not going to test it in front of you, because that would confuse you guys, or at least it would confuse some of you. But I am testing that, because if that works out, that'd be really, really cool, actually, because that would just make a lot of people's lives a bit easier. Plus, what's DE? 6.66666 squared equals the square root of that. Okay, so we'll see if the answer that I just got was right. Okay, so AE, basically the y portion of this, the height of this, is 12. So that means that the diagonal times the sine equals the opposite, right? Or AD, which is the 7. Oop, no, I'm sorry. The y portion of this is not 7. The y portion of this is this 12 that we just found out. AE in the y direction. You cannot use Pythagorean theorem. I was wrong. I thought it might have been right, but I was wrong. So that's equal to 12. Right? The diagonal times the sine gives us the height. Okay, hopefully that's clear. So then we get that the diagonal times, what's the sine? The sine is 0.6. So 0.6 equals 12. Diagonal times 0.6 equals 12. So then if we divide both sides by that 0.6, we get 12 over 0.6, and that's what? Handy dandy calculator. Oh, slow computer. 12 divided by 0.6 equals, we get 20. Oh, that's convenient. 20. Handy dandy dandy. Okay, so our we have our AE being equal to 20. Let's just slide that right over here. Hopefully the fact that my computer is spazzing and being slow has no effect on the video that you're seeing, otherwise some of this might not be making sense, but I hope it all does. I hope that all makes sense. Let's draw in those the big blocky arrow to show us that we've figured out that part. And let's think about it. This is pulling down, and this is pulling down. So that means that this has to be pushing back up, right? That should just kind of follow, right? Because if A is getting pulled down by these two, E has to be pushing. Hear me right now? Oh, okay. Sorry if something weird just happened there on the video, and my computer froze for a completely unknown reason, since I'm only running 2 applications, and one of them is Paint. But basically what I just said was that A is getting pulled by C and D, so E has to be pushing it back up. Hopefully that makes sense. So what else? What can we do next? Well, how about we solve for this AB thing here? And this one should actually, again, it shouldn't be too hard. It's kind of like our AE part. So let's, oops, sorry. Let's get rid of all this crap. Okay, so A is getting pulled this way by C, so A is getting pulled this way, and A is also getting pushed this way by E. So that means that B has to be pulling back with that same amount of force. So we can say that our force AB is just going to be equal to our force AC, right, this, but in the X direction, basically the amount that C is pulling A this way, plus the amount that A is being pushed by E in that same X direction. So what do we get? Okay, well, let's plug stuff in. AB equals, what's AC in the X direction? Well, we figured that out. I think that's in my second video, but that's the AC cosine of 37, and what we ended up getting is that that's actually the same as CD. So I'm just going to kind of fill that in there. If you're confused about that, go back to I think it was 2 videos ago we did that part. But you'll see that if you take our AC value our AC value 8.33 and multiply it by the cosine of 37, if you multiply that by 0.8, you will get this 0.66666. So then that plus, what's AE in the X direction? That's going to be our AE, right, our 20 times the cosine of 37, right? Because if this is the angle, the cosine is that horizontal piece. So what's 20 times the cosine of 37? Whoops, wrong window. Start, calculator. Sorry, slow computer. I don't know why it's being slow all of a sudden, because it's like I'm not running any more applications than normal. But okay, so we said that our horizontal piece right here is going to be AE, the hypotenuse, the diagonal, times the cosine of the angle. So we're going to say angle is 37. Oh, silly me. Okay, our AE is 20. Our angle is 37, and we have that the cosine is 4/5. So if we multiply 20 by 4/5, we actually get, what, 20 times 4 over 5, right? 20 times 4/5. So here we get 80 over 5, and that turns out to be 16. 80 divided by 5 is 16. Did I do that right? Let's check just for the heck of it. So we've got 20 times. Oh wait, crap. We're gonna take the cosine of this angle. Then we're going to multiply that by 20, and we get 15.9. Yeah. So basically, with the values that we had, the 0.6 or the 0.8, that was right. So plus 16, and that's going to be equal to 22.66. That's our value right there. And that's our value for AB. Again, I didn't think that wasn't too hard. That wasn't too much work. Hope that all made sense. If not, watch the video watch that portion of the video one more time. If it still doesn't make sense, let me know, because that means I'm doing something wrong. And I hate doing things the same way that Dr. Christo does, because Dr. Christo, well, because anyone who came here obviously didn't understand Dr. Christo. So my objective is not to be like him at the moment. So A is getting pulled in this direction, pushed in this direction. So that means that C is pulling it this way, E is pushing it that way. So that means that B has to pull it backwards this way, right? I mean, B has to pull it backwards in this direction. Something has to be kind of opposing, and that means that A is also pulling B in that direction. Now you figure, if B is pulling on A, then B is also going to be pulling on the ground, right? Because it has to be kind of be pulling on something. And B is pulling on A, so what's keeping B from flying that way? B is pulling on the ground. So actually, as it turns out, whoops, wrong tool. I'll never get a hang of this. So actually, as it turns out, this AB right here is the same force that's holding B to the ground. It's the same magnitude in this case. So the ground to B is also 22.6. So 70% done with our problem here. Text. 70% done with our problem. Okay, what's left to do? Well, how much is E? You figure E is pushing A and D away. One sec. E is pushing A and D away. That means that E has to be pushing away from the ground somewhat. And that it should make sense that the value of E pushing into the ground is going to be equal to, well, the amount that D is pushing at E, so DE, plus the amount that A is pushing at E in the x direction. So A, E in the x direction. So EG equals, what's DE? DE is 6.66. Plus, what's AE? Well, I think we actually just figured that out. Oh, no we didn't. AE, you figure this this hypotenuse here is 20. Oh yes, we did just figure this out. We just figured out that the horizontal part of that is a 20 times the cosine, and we came up with it being equal to 16, I think. So this also equals 22.66. Whoops. So here's where we get kind of actually a bit of a neat answer, because it really makes sense now in a sec. You'll see. So the amount that E is pulling on G, right? Or rather pushing on G, because you figure if E is pushing A away, and if E is pushing D away, well then what's keeping E from just sliding right through the ground? Well, the ground is pushing back on E. And now it should kind of make sense that the amount that B is pulling in this direction is going to be equal to the amount that E is pushing in that direction, that E is being pushed by the ground. So B is pulling on the ground, E is pushing on the ground, and they cancel out, right? Because it's not moving anywhere, because it's stationary. And then, let's see. What's the reactant force on B? How much is B resisting sliding up and down here? Well, that's 0, right? There's no vertical forces acting on here, so that one's really easy. That's 0. And the next one's almost as easy. This one you can actually figure out just kind of like by a little bit of logic. You figure if C and D are getting pulled down, and E is resisting that, well then E has to also be pulling upwards, or rather the ground has to be pulling, or the lighthouse, or whatever the wall is, it has to be pulling E upwards with the total of that, but 12. Whoops. 12. So there we solved it. In the next video I'm going to do a bit of torque analysis. If any of this didn't make sense, watch the video twice, and if that still doesn't make sense, let me know and I'll fix it. Next video I'll be doing torque, so I'll see you then. Time to go not let my thing go on fire.